All right, in this section, we're going to look at quadratics. We're going to end up doing two videos. It's a little bit lengthier here. So the first video, we're going to look at solving quadratics by factoring, and then a couple of different varieties of the types of problems you might look at, like rationals and whatnot. We'll do a couple examples of applications also with quadratics. So when we're solving quadratics by factoring, we're going to use something called the zero product property, and that says that if A times B is equal to 0, then that's going to mean that either A is equal to 0 or B is equal to 0. Okay, and so we're going to do a couple examples we're solving. Oops. So let's see. We're going to solve 35 equals negative x squared minus 12x. And so what we want to do when we're solving a quadratic, with the exception of completing the square and the square root property, square root method, we want to set the equation equal to 0 and then try to factor it or use the quadratic formula. So here we're going to be doing factoring, and it's easier to factor if the quadratic term is positive. So here we have a minus x squared. So to make this easier, what we're going to do is we're going to move both of the minus x squared and the minus 12x to the other side so that the factoring is easier. So we're going to add x squared and add 12x to both sides. And then that'll set the equation equal to 0. And then we can go ahead and factor that there. Okay. So a product of 35 that adds up to 12 is going to be 5 and 7. Okay, so once we've got it factored, here's our A times B. And so now what we'll do is we'll say x plus 5 equals 0 or x plus 7 is equal to 0, and we'll solve those two linear equations. So x plus 5 is equal to 0 or x plus 7 is equal to 0. And we'll solve them very similarly. Subtract 5, x is equal to negative 5. And subtract 7, x is equal to negative 7. So those are our two solutions for our quadratic equation. So if we're solving an equation that has just an x to the first power, we can expect one answer. Quadratic, where we have an x squared, we should expect two answers. Sometimes we might have a repeated answer. And x cubed, you can expect three answers, etc. Anyways, all right, so let's look at another one, 25x squared minus 16. This is also a factoring problem. It is a difference of squares. 25, or sometimes we call it a difference of two perfect squares. 25 and 16 are both perfect squares, and we have a difference in between them. That factors into a minus b and a plus b. So hopefully we can recognize that. So 5 times 5 is 25, 4 times 4 is 16. So that factors into 5x minus 4. 5x plus 4 equals to 0. And then we'll set each factor equal to 0, and we'll solve those two linear equations there. Okay. So we'll add 4 to both sides. And we have 5x is equal to positive 4. Divide both sides by 5. And we get x is equal to 4 over 5. Alternatively, we'll subtract 4 from both sides, and we'll have 5x is equal to negative 4 on the other equation. Divide both sides by 5. X is equal to negative 4 over 5. Okay. There is another way we could solve this equation. 25x squared minus 16 is equal to 0. It's called the square root method. So we would add 16 to both sides, and then we would divide by 25. And what we would want to do is, to get rid of the square, we would take the square root of both sides. So we take the square root of the left side, take the square root of the right side, and so we get x is equal to 4 over 5, which gives us one of the answers here. And so when we do the square root method, we'll probably do that in the next video. Every time I take the square root in the act of solving, I need a plus and minus there. That way that I can get both the positive and negative versions there. So that's certainly, that's probably how I'd want to do that problem, but we haven't talked about the square root method. We just have factoring for the time being. Okay, So we're going to look at another example of factoring, and this one we'll be using another special factoring formula, and then we'll look at some other variations of problems we can run into. So number 3, we have 36x squared plus 60x plus 25 is equal to 0. This is the perfect square trinomial, a squared plus 2ab plus b squared. So what I look for is 36 and 25. Those are both perfect squares. Now, to make 36, I need a 6, and to make the 25, I need a 5, okay? So, and then we'll just put in the variable, the x on the 6 there. The question is the middle part, the 2ab, is that 60x? So we're going to verify that that's the case. So this would be 2 times 6x times 5, and that in fact is the 30x. It's not the 30x, it's the 60x, excuse me. That is the 60x over here in this problem, so that tells it's a match, and so this is going to factor into a plus b quantity squared, or we could write out 2 of them. Okay, so that's what we're going to get going on here in just a moment. Let me erase all this extra stuff. So that's going to be a plus b times a plus b, or we can write it as a plus b quantity squared. Okay, so 6x plus 5 and 6x plus 5 is equal to 0. And then we'll use the zero product property and set each factor equal to 0. They are the same factor, but so there's no need to write it twice. And so we'll just solve the equation like we normally would. So 6x is equal to negative 5, divide both sides by 6, and x is equal to negative 5 over 6. And you see how you have 2 factors of 6x plus 5. We'll say that this is a root. Root's another word for answer or 0. This is a root of multiplicity 2, and why we would say 2 is because we have 2 factors of 6x plus 5. Let's say I had, x minus 4, x minus 4, x minus 4, x minus 4, and x minus 4. We'll do something quite longer. X equals 4 would have the multiplicity of 5 there because you have 5 factors of x minus 4 there. Okay. All right, let's go ahead and look at another example here. Let's say that we have 7x plus 9 equals x plus 7, and then, 7x plus 9 times x plus 7 equals 47. We don't have a 47 product property. I mean, there's probably some sort of guess and check type of thing that we can do, but we don't really want to do that. So the strategy here is to FOIL the left-hand side and then subtract the 47 over and hope the thing factors. So we'll go ahead and FOIL. So 7x times x, 7x squared. 7x times 7 is 49x. 9 times x is 9x. 9 times 7 is 63. That is equal to 47. Set the equation equal to 0 by subtracting 47 from both sides. 7x squared plus 58x after you combine your like terms is plus 16 is equal to 0. Okay, so this is going to be a little bit of a more difficult factoring problem, so I'm going to use the AC method to factor this one. It's actually not too bad because the 7 is a prime, but we'll go ahead and do the AC method, which says we're going to multiply the a and the c coefficients. So 7 times 16 is going to be, I think, 112. And then the linear coefficient is the b, that's 58. So what we're looking for is factors of 112 that add up to 58. So I'm going to start writing out the factors of 112. That's 1 times 112, 2 times 56, and we didn't have to go very far, so 2 times 56 is 112, 2 plus 56 is 58. So we could write that down. 2 times 56 equals 112, and 2 plus 56 is equal to 58. So that's what we want there for doing the diamond here. So that gives us the correct factors, and so we're going to handle this by doing factor by grouping. So 7x squared plus 2x plus 56x plus 16 equals to 0. We'll group the first two, which have a GCF of x, 7x plus 2. The second two have an 8 in common, 7x plus 2. Common factor of 7x plus 2, so we will factor that out. 7x plus 2 times the leftovers, x plus 8, and that's equal to 0. So now we can use the zero product property. So that says 7x plus 2 is equal to 0, or x plus 8 is equal to 0. Subtract 2 from both sides and then divide by 7. X is equal to negative 2/7. On the other one, all we'll need to do is subtract 8, so subtract 8 from both sides, and we get x is equal to negative 8. Okay, so that's it there. So this one, I think you got one or two like this in the homework. So this is a general strategy. Maybe you get nicer factoring, maybe you get a little bit larger numbers like this one. Okay, the next one we're going to look at is a rational equation. We're going to have rational expressions on both sides of the equation. So x plus 1 over x minus 1 equals negative 7 over x plus 3 plus 8 over x squared plus 2x minus 3. Now, like what we did with the linear equations that involved fractions, we're going to, in general, want to clear the fractions. So we need to identify what the common denominator is, or the least common denominator. I might call it the least common multiple, or LCM, and that means the LCM of the denominators. So we want to identify that. What that will require us to do is to factor any denominators. And after we've done that, we'll identify the LCD. So I'm going to rewrite the same problem, and I'm going to leave some room so that once I have identified the LCD, I can go ahead and just multiply both sides of the equation by the LCD. And I went ahead and factored x squared plus 2x minus 3. That factors into x plus 3 and x minus 1. So you have an x minus 1, an x plus 3, and then you got two of them over here. They're all to the first power, so all we need is an x plus 3 and an x minus 1 for our LCD. Okay. And in this case, I call it the LCM. And when I say LCM in this context, I mean the least common multiple of the denominators. That's the same thing as the LCD in this context. Okay. The other thing we got to talk about is we do have restrictions. Thou shall not divide by 0. And so we're going to take each individual factor in the denominator and say that cannot be 0. So x plus 3 cannot be 0, and x minus 1 cannot be 0. So that tells us x cannot be negative 3 and x cannot be 1 when we solve that, okay? So after we solve it, then we'll run our check. We'll see what our answers look like. If they're one of our restrictions, we'll throw that answer out. So now we have the LCM. We're going to multiply everybody by that LCM. And I'm going to do it over 1 because they're all fractions, and that's just going to help me line things up when we do some cross-canceling. Okay. The first one, the x minus 1's cancel. And you're going to have x plus 1 times x plus 3 equals the x plus 3's cancel, and you're going to have negative 7 times x minus 1. On the last term, both the x plus 3 and the x minus 1 absorb or cancel out, so you're left with 8. What we'll need to do now is on the left-hand side, we'll need to FOIL. On the right-hand side, we'll distribute the minus 7. We'll collect like terms, so x squared plus 4x plus 3 equals minus 7x and plus 15. This is quadratic, so we're going to add 7x and subtract 15. So add 7x and subtract 15, and we're going to do that so that we can hopefully factor. So x squared plus 11x and minus 12. And then we're going to migrate up here. That factors into x plus 12 and x minus 1. Setting each factor equal to 0 using the zero product property, we have x plus 12 equals 0, or x minus 1 is equal to 0. Subtract 12 from both sides, x is equal to negative 12, or add 1, x is equal to 1. And you notice that we got an answer of x equals 1. That was one of our restrictions, and so we got to throw that one out. And I'll go ahead and say that x equals 1 is an extraneous solution, which means it's an answer that does not work. So for me, if you just write down x equals 1 and you cross it out like I did there, that's perfect. If you're entering in the numbers, your answers into Lumen or MyOpenMath, what you need to do is only enter the good answer. The bad answer is the one I've crossed out, so you won't enter that one in. If you're doing it on a test or some sort of in-class activity, then I'd want to see something like this, where you show me the two answers, one of them you box or circle or something like that, highlight it, somewhere to indicate that that's the correct answer, and then cross out the other answer. Okay. So anytime we have variables in the denominator when we're solving an equation, later on we'll have some square roots in equations, so we'll call those radical equations. Anytime we have that, then we need to check our answers, and later on with logarithms also. Okay, so that concludes kind of some of the factoring examples in terms of just like math problems. Now we're going to get into some applications. So we're going to look at a couple of applications of geometry, and then we'll get into a few of the uniform motion problems. So let's see what we got going on for the applications here. So we'll do two geometry type problems, and then we'll look at uniform motion. Okay, so number 6 says, let's speed it up. It says a rectangle is drawn so that the width is 3 feet shorter than the length. The area of the rectangle is 40 feet squared. Find the dimensions. Okay, so we'll go ahead and draw ourselves a rectangle. And you guys can make fun of my crooked rectangle. We'll just pretend that it's, well, I'll try to fix it. We'll try to make it look a little bit nicer. Okay, and then we'll trim this down a little bit. Still doesn't look great, but that's okay. All right, so here's a rectangle. We've labeled the length and the width. And it says the width is 3 feet shorter than the length. So width equals the length, and then subtract 3 from that, and that's going to be 3 shorter than the length. Okay, the area of a rectangle is length times width. We know the area in this particular problem is 40. That's going to be equal to the length times the width. The width is given to us, or we had to come up with it. The width is L minus 3, the length minus 3. This is going to be quadratic, because when I distribute the L, I'm going to get an L squared minus a 3L. So we're going to anticipate that, and we're going to subtract 40 from both sides. So we get 0 is equal to L squared minus 3L minus 40. I'm going to come over here because I think the Dorsey little watermark or something's right there. So I'm going to try to avoid that. So I'm just going to migrate over here. And that factors into L minus 8 and L plus 5. Okay, solving that, we get L minus 8 equals to 0, or L plus 5 equals to 0. And what I should say is setting each factor equal to 0, and then solving. We get L is equal to 8, or L is equal to negative 5. Now, if this was a math problem not as tied to some sort of application, L equals negative 5 would be fine. But I don't know what negative length means. You know, if you go down to Home Depot or Lowe's and you say, "Oh, I want negative 5 feet of rope or chain or something like that," they're just going to look at you funny. So, but 8 feet makes sense. So the length is going to be 8 feet, and the width is 3 feet shorter. So the width is going to be 5 feet. Okay. All right. Let's look at another application. This time we're going to look at a triangle. So let me hurry it up a little bit. Okay, it says the shortest leg of a triangle is 1 meter shorter than the other leg. The hypotenuse of this triangle is 5 meters. What are the lengths of the two legs? So because they said the word hypotenuse, hypotenuse is going to be a right triangle. I've drawn a right triangle over on the left there, and I've labeled the sides A, B, and C. You see the little box here for the right angle. The hypotenuse is always opposite of the right angle, and it is going to be the longest side. Okay, A and B we usually call the legs, and C is the hypotenuse. And then I've drawn an arrow to indicate the hypotenuse. The Pythagorean theorem says that a squared, says a squared plus b squared is equal to c squared. So in our particular problem, they say that the hypotenuse is 5, and then we have the shortest leg is 1 meter shorter than the other leg. So we can call the other leg x. Then the shortest leg would be 1 meter less, or x minus 1. Okay? And then we're going to drop that into the Pythagorean theorem, which says x squared plus x minus 1 squared is equal to 5 squared. So we'll have x squared. We'll go ahead and come over to here to but to expand x squared minus 1 off to the side there. That means x minus 1 times x minus 1. And so we'll FOIL that out. X squared minus x plus 1. X squared minus 2x and plus 1. Plus x squared minus 2x plus 1 is equal to 25. This is quadratic, so we would like to do two things. Combine like terms, so add the x squareds together and also subtract 25 from both sides to set it equal to 0. So we have 2x squareds, a minus 2x, and a minus 24 equals to 0. Now, we'll want to factor this, but what I notice is all my coefficients are even. The coefficients being 2, negative 2, and negative 24. So I can divide by 2, and that is my GCF. And why I would want to do that is it makes the number smaller, it makes the problem a little easier. So you get x squared minus x minus 12 equals to 0. And we'll go ahead and factor it, but I'm going to go ahead and erase the left-hand side here, and we'll go ahead and do it over on the left-hand side. So you have x squared minus x minus 12 equals to 0. That'll factor into x minus 4 and x plus 3. Setting each factor equal to 0, we're going to have x minus 4 equals 0, so you get x is equal to 4, x is equal to negative 3. We're talking about a length here, so we're going to throw out the negative 3. X is 4, that's the other leg is 4. The shortest leg is going to be 1 meter shorter than that, so 4 minus 1 is 3. All right. So the last part of this video is we're going to look at a couple of examples of uniform motion. We're not going to really get into any quadratics with the exception of the last problem, but certainly quadratics can come up when we're doing this, and let's see what we got. So when we're looking at uniform motion, we're going to use the fact that the distance traveled is going to be equal to the rate, which will be a speed, times time, or distance equals RT. Okay, so for example, if you're traveling 75 miles per hour and you travel for 2 hours, the units of hours will cancel, and 75 times 2 will be 150, and that would be miles there. So, and we are making the assumption that your speed is going to be constant, or maybe we just ballpark it and say this is what your average speed is. Okay, now if I take distance equals RT and I want to solve for example time, I would divide both sides by R and you get distance over rate is equal to time. If I wanted to solve for time, or is that the one I just did? Solve for rate, sorry. Divide both sides by t, you get distance over t is equal to r. Now we can summarize that with a little picture here. It's a triangle, so distance and then RT like this in a triangle. So if you want to know what the time is, you cover up the time and you have distance over R, distance over rate. If you want to know what distance is R times time. If you want to know what the rate is, that's distance over time. So that kind of helps us out. We're going to go ahead and do an application, but we're going to speed this up, and then we'll go ahead and read it. Okay, so it says a plane can fly if I can talk, a plane can fly 480 miles in the same time a car travels 90 miles. If the car travels 130 miles per hour slower than the plane, find the speed of the plane. And notice I've already underlined the same time, so that's going to be the key here. So the time, the plane's time and the car time is going to be the exact same thing. So if we're taking our little diamond here, we can cover up time. And so we're looking at plane distance over plane rate, and that's going to be the same as the car distance over the car rate, or car speed. Okay, so plane time is equal to car time. Okay, plane distance is 480, and its speed, we don't know, we can call it x, that's fine. Car is distance of 90, and its speed is 130 miles per hour slower, so that's going to be x minus 130. There's an alternative to this. You could also say that you call the car's speed x, then the plane would be 130 miles per hour faster, and you get x plus 130 over here. And those would be your denominators. It'll work out the same, and you'll get the same answer. I'm going to stick to the one that I have going here. Okay. So what we got here in terms of solving this is we can do cross multiplication, because the fact that we have one fraction equals another fraction. You don't have to, but I would suggest doing the cross multiplication here. Cross multiply. So 480 times x minus 130. And that's going to be equal to 90 times x. Distribute the 480. So we got 480x and then minus 62,400, and that's going to equal 90x. This is linear, and that's okay. We can solve a linear. Subtract 480x from both sides. Negative 62,400 is equal to negative 390x. Divide both sides by negative 390. Okay? And so we get 160 is equal to x. Okay. Then if we want to find the car time, subtract 130 from that. So plane is 160 miles per hour. The car is going to be 30 miles per hour. Okay. If you had done the other way I was mentioning, you said this is x plus 130 and this is x, then you get x is equal to 30, and then you'd have to add 130 to get the 160. So you can still get the same answer. Okay. We're going to look at one more like this, and then a uniform motion problem where it actually becomes quadratic. And sometimes they're rigged so they'll factor. I think the one that I have doesn't quite factor, but it's still good in terms of taking a look at what we got going on here. Going on in coming up with quadratics, or quadratics that appear in uniform motion problems. Okay, so let's go ahead and speed this up so we can read it. Okay, so it says a woman can bicycle 50 miles in the same time as it takes her to walk 10 miles. She can ride 10 miles per hour faster than she can walk. How fast can she walk? So this one has the same setup as the other one. It has that same key phrase of same time. So if we got same time, that means we're looking at distance over rate. So we're looking at bike time equals walk time. Bike distance is 50, and the speed, we don't know, we can call it x. That's going to be equal to 10 over, and then she is 10 miles per hour slower. So her distance is 10, her speed is 10 miles per hour slower than her bike speed, so x minus 10. Alternatively, if you wanted to, you could call her walk speed x, then her bike speed would be 10 miles per hour faster, so that'd be x plus 10. So you can do that also, you'll get the same answer. Your x will be different, but what it is tied to will be the same, so you get the same answers. All right, fraction equals a fraction, so let's go ahead and do our cross multiplication. Okay, so 50 times x minus 10 equals 10 times x. Distribute the 50. Subtract 50x. Divide by negative 40. So divide by negative 40. And we get x is equal to 12.5. And that is her bike speed. That is her bike speed. So to find her walking speed, we need to subtract 10 from that. So her walking speed is 12.5 minus 10. So her walking speed is 2.5 miles per hour. Okay. All right. So we're going to look at one more problem here. And I'm going to be interested in kind of setting it up and then also seeing that a quadratic comes out of it. There may be some problems where the quadratic that comes out factors. The one that I have does not factor nicely. So I'll go ahead and do the quadratic formula with it kind of briefly at the end. But then we'll have another video where we go into the quadratic formula a little bit more in depth. Okay, so the last problem we'll look at, and let's speed it up. Okay, so it says a family is on a road trip. The speed limit during the first 100 miles of the trip is 55 miles per hour. And the speed limit during the last 205 miles is 75 miles per hour. How many miles per hour over the speed limits must they drive in order to arrive at their destination? Excuse me. We're going to make the assumption that how much we're speeding over the limit is going to be the same. So, you know, if we're going 10 miles per hour over when it's 55 miles per hour, we're going to be going 10 miles over when it's 75 miles per hour. Okay, so we'll go ahead and set up our little triangle there. And so we need to look at how things are divided up here. So it looks like they say something about reaching the destination in 4 hours. So we've got two parts of the trip there. So let's see what we can do with that. So if we add the first part of the trip time plus the second part of the trip time, that's going to be equal to 4 hours. So if we're doing time, that's going to be distance over rate. So the first part of the journey or trip or whatever, they went 100 miles. And the speed limit is 55, and we're going to say x is how much they're speeding over the limit. So 100 over 55 plus x. The second part, they traveled 205 miles, and that's going to be 75 is the speed limit, and then we're going to assume that they speed the same amount over the limit, so plus x, and that's equal to 4 hours, okay? So here's where the quadratic comes into play, because we're going to clear the fraction, and we're going to have 55 plus x times 75 plus x, and that's going to give us our quadratic. So our least common denominator, LCM, is going to be 55 plus x, and then 75 plus x, okay? And so it's going to be kind of a mess, all right? So I'm going to rewrite it, and then we're going to multiply everybody. We're going to multiply everybody by the common denominator here. Okay, so there's the first term multiplied by the common denominator. I'm going to do the common denominator over 1 plus, here's the second term, common denominator over 1. Oops, and no, we're okay. And anything we do to one side of the equation, we have to do the other, and then we got 4 times 55 plus x, and then 75 plus x, okay? All right, then we get to play the canceling game. So the 55 plus x is canceled. Then you're going to have 100 times 75, 7,500. 100 times x is 100x. On the second part, the second term, the 75 plus x is canceled. You're going to have 205 times 55, which is 11,275, and then 205 times x, 205x, equals 4 times 55 times 75 is 4125, plus 55 times x is 55x, and 75 times x, 75x. Add those together, you get 130x, and then x times x is x squared. All right, so we're going to move up to the top because I'm out of real estate. Okay, so just rewriting the problem now. We're going to distribute the 4 and then also combine like terms. So 18,775 plus 305x equals 16,000 something plus 520x plus 4x squared. This is quadratic, so we would like to set it equal to 0. So we're going to subtract 18,775 from both sides. Okay. And that's the difference. Subtract 305x from both sides. And all I did was I wrote it in descending order there. Okay. Now, this one does not factor. So if it's rigged nicely, this will factor. So if you're doing the application worksheet in class, something about 2 parts of a journey, that one's rigged to factor. This one won't. So we'll have to use the quadratic formula. I'll go into more detail in another video about quadratic formula. So it's going to be negative b, that's negative 250, plus or minus b squared, which is 215 squared, minus 4 times negative 2275, and that's all under the square root, divided by 2 times a, which is 4. It's going to be negative 215 plus or minus square root of 8. It looks like this didn't get erased real good. I think that was 8. 625. Yes, 625. Sorry about that. Okay. And denominator is 8. So in your calculator, x equals negative 215 plus square roots of 82625 divided by 8. You'll need the parentheses here and here. That's going to give us approximately 9 miles per hour. If we do the other one, negative 215 minus square roots of 82625 divided by 8. That's going to be approximately negative 62. Because we're talking about a speed, I don't think we're going to be driving in reverse on the freeway. We probably wouldn't make it that far. Wouldn't be getting pulled over. 9 miles per hour seems reasonable. So this family, on average, was going 9 miles per hour over the speed limit, which seems pretty consistent. Probably a little bit on the slow side with what we would observe in Houston here. Okay, so this is a bit of a longer video. I think the second part will be a little bit shorter. We're going to be doing square root property, completing the square, and then getting into the quadratic formula. So that's it for this video.